NVMe-over-TCP is a method of encapsulating NVMe commands in TCP. It allows us to have one of our devices use a storage medium that is physically on another device. But despite the name, this feature is not limited to NVMe drives. It can be used with any block device, a flash drive, a RAM disk, SATA drive, or an SD card. It does not matter. Furthermore, since this solution is working at a very low level, you can expect the best possible speeds that you can squeeze out of network-based storage. However, there is an implication that a single block device on a host can only be used by a single client device. So it is not a file sharing solution like SMB or NFS. While theoretically it is possible to access the contents of a single drive from multiple client devices, you still have to keep it to one client at a time. On the security side, you have to respect that this is a data center functionality and it has to be kept very well guarded. You do not want to expose such low-level hardware control to the internet or even your office LAN. You want to keep it on as small of a network as possible. Now with the Router S device, when you enable NVMe over TCP, by default you make it available to all of its interfaces and any networks that it is part of. So unless your device is on a single isolated network, you'll want to set up firewall rules based on the principle of least privilege. You will also want to use authentication, even if it is to prevent yourself from accidentally erasing the wrong device. There is a simple NVMe TCP password property. I'll show you that in a minute, but there's one more thing I should mention. When it comes to encryption, our implementation does not use TLS for data in transit, so if you're worried about someone eavesdropping or doing something bad within your network, your best bet is to set up encryption on the client side. That way you can accomplish essentially the same thing as you would with TLS, but without having to handle certificates. So if you want to encrypt your NVMe over TCP, you'll want to use the software-based disk encryption that comes with the ROS package. To learn the setup, you can click the link in the corner. Just make sure you adapt it for your drive on the client side. If you do that correctly, only encrypted data will get transmitted, and the key will only get stored at the client device. That is one way how you can beef up your security, but now let's move on with the basic NVMe over TCP configuration between two Router S devices. My server has an NVMe drive available. To donate it to my other router, I can simply use the set command to change the NVMe TCP export attribute to yes and set the NVMe TCP port to the typical 4420. After applying, the drive is no longer mounted on this device. Now on the client device, we can go to the disk section and enter add type NVMe TCP, followed by NVMe TCP address and NVMe TCP name. The name refers to the NQN property, and in Router S it will simply be the same as your slot name on the host. Optionally, pick a slot name to use in the client device. That adds it. In this case, the drive is already formatted to ext4. On the file list, there is now a new storage location, and we can begin using it straight away. Alright, but what if we want to use authentication? No problem. If we look at the detailed view of our drive on the server side, we can see there are a couple of NVMe related properties we can set. In particular, we need to set the NVMe TCP server allo host name to what will essentially be our username, and then the NVMe TCP server password will be our password. Now, when we check the client again, the remote drive is no longer reachable. To fix it, we simply have to add the NVMe TCP host name and the NVMe TCP password properties. If you would like to use this drive on a computer instead, we should first remove it from our client router. Then you want to make sure you have the needed NVMe package installed and loaded with modprobe. With those prerequisites, you can enter the NVMe connect command with type TCP and address of your router. The small s flag specifies the port. N flag is the drive slot on your router. And then, if we are using authentication, we can specify the username we set up with the Q flag. A significant difference here is that we cannot simply use the password we set up before. Instead, we have to use longer secret using the capital S flag. If we go back to our router and look at the details of our drive again, we can see that there is now a new server secret property that we have to copy and finalize our connect command. You should not get any errors, and if everything has executed correctly, you should now have a new NVMe device available. If you then create a folder and mount the drive, you should find there is the file we created earlier from the previous client router. Alright, that is as far as we will go in this demonstration. Let us know in the comments what you think about our NVMe over TCP implementation.